Hi, this is MD Shavana Sultana, working as Associate Professor in the Civil Engineering College, Civil. In the last lecture, I explained about the arc discharge method, that is the preparation of the carbon nanotubes. In this, the first method is the arc discharge method, and the second one is the laser evolution method. Today, I want to discuss about the chemical vapor deposition method. This method was first developed in 2007 at the University of Cincinnati, USA. During chemical decomposition method process, the substance was prepared with the help of metal catalyst nanoparticles such as nickel, R, cobalt. The substrate is heated to 700 degrees centigrade, and the mixture of nitrogen and carbon containing acetylene. Here, this is the diagram. It's a construction of the chemical vapor deposition method. In this method, the apparatus consists of the reaction chamber, and the heating coils are there to generate the electricity, to produce the heat, and to give the heat to the system during the process of the reaction. And one inlet and one outlet is present. And the substrate was prepared with a layer of metal catalyst nanoparticle, which is made up of the nickel, iron, or cobalt. And the substrate is heated at 700 degrees centigrade, and a mixture of nitrogen and the carbon containing acetylene gas, which is a mixture of the nitrogen and the carbon, which is known as the nitrogen, which is known as a carrier gas. It is passed. The carbon nanotubes grows at the surface of the catalyst particle, where carbon containing gas is broken, and carbon is transported to the edge of the particle, where it forms Cnt. It is a carbon nanotube. Fluidized wet red reactor is most widely used for carbon nanotube production. Chemical vapor deposition method is the most promisable for industrial production. Carbon nanotube, it is having the low cost and direct growth on the catalyst surface. The use of the catalyst reduces the need for high temperature, and the yield obtained or the yield can be achieved by this method is very high. That is 90% of the yield is obtained by this method. Chemical vapor deposition method is the most widely used for commercial production of carbon nanotubes. Coming to the properties of the carbon nanotubes, it is having the good strength, and carbon nanotubes are one-dimensional conductor along the tubular axis with conductivity either metallic or semiconducting in nature. Coming to the second property, carbon nanotubes are the strongest and stiffest material due to the presence of covalent sp2 bond between the individual carbon atom. And coming to the hardness, standard single wall carbon nanotube withstands a pressure of about 25 gigapascal without deformation. And it is having, carbon nanotube is having the kinetic property. Multi-walled carbon nanotube possess the kinetic property, which are multiple concentric nanotubes nested within one another, which exhibit a striking telescopic property, whereby the inner nanotube may slide without friction within its outer nanotube. This property is utilized to create a smallest rotational motor and gigahertz mechanical oscillator. Coming to the electrical property, because of the symmetry and unique electronic structure of the graphene, carbon nanotube is a semi-conducting with a very small band gap between the valence band and conducting band. Because the electrons propagate only along the tube axis and involve a quantum effect, carbon nanotube is referred as one-dimensional conductor. Because of this reason only, it is having the tubular axis. For that reason, it exhibits one-dimensional conductor. Coming to the optical property, the optical property of the carbon nanotubes is due to the absorption of the photoluminescence and Raman spectroscopy, which allows quick and reliable characterization of this nanotube. In terms of non-tubular carbon content. Next, carbon nanotube, it also exhibits electromagnetic wave absorption. Carbon nanotube possess microwave absorption characteristic, which is useful for military radars and to better the stealth characteristic of aircrafts. Carbon nanotube are very good thermal conductor and exhibit the property of ballistic condition. Single wall nanotube at room temperature has thermal conductivity, which is more than the copper metal. The thermal stability of the carbon nanotube is 2800 degrees centigrade in a vacuum and 750 degrees centigrade in the air. Toxicity, carbon nanotube possesses the toxic nature. Under certain conditions, a carbon nanotube can cross the membrane barrier and reach the organs, which induces harmful effects like inflammatory, fibrotic reaction, and can cause cell death. So these are the properties of the carbon nanotube. Coming to the next applications of the carbon nanotube. Because of the superior magnetic mechanical properties, carbon nanotubes are used to make space elevators bulletproofing clothing. Carbon nanotubes are used for producing Cnt fields, that is carbon nanofield effect transistors, provided with digital switching using a single electron semiconducting nanotubes. And it is also used recently for making the nanotube polymer composites, which are used for making electrical wires, electrical cables, because of their high conductivity. A paper battery is a battery engineered to use a paper thin sheets of cellulose infused with carbon nanotubes. And here, the carbon nanotubes acts as an electrode, allowing the storage device to conduct the electricity, which can provide steady power output comparable to the conventional battery. Coming to the next application, one of the promising application of the carbon nanotube is their use in the solar panels due to their strong absorption of radiations like UV, visible, IR. The solar cell developed at NIT, New Jersey, America, contain a mixture of carbon nanotubes and buckyballs, which is known as fullerenes, which I will tell in the next lecture. And they are used to store the hydrogen to be as a source fuel. That means whatever the hydrogen which is generated, in that process, the carbon nanotube is used as a fuel cell to store the fuel gas like hydrogen. And the carbon nanotube is also used in the medical field, mainly the single-walled carbon nanotube, which is inserted around the cancer cells and excited with the radio waves, which causes them to heat up and kill the surrounding cells. And the carbon nanotube is a suitable scaffold materials for bone cell proliferation and bone formation. Coming to the last application, optical power detectors. A spray on the mixture of carbon nanotube and ceramic coatings gives unprecedented ability to resist the damage while absorbing the laser lights. So this is about the applications of the carbon nanotube. Coming to the next topic, which is known as fullerenes. What is a fullerene? A fullerene is any molecule composed of entirely of carbon in the form of a hollow sphere, ellipsoid, or tube. Spherical fullerenes are also called buckyballs, as they resemble the ball used in football. Fullerenes are similar in structure to graphite, which is composed of straight graphene sheets of linked hexagonal ring, and it also contains the pentagonal rings or heptagonal rings. The first fullerene molecule was proposed in 1985 by Richard Smalley at Rice University, USA. They were awarded the Nobel Prize in the year 1996 for their work. The name fullerene was given as a homage of Buckminster Fuller. He is also one of the scientists whose geodesic domes the molecule resembles. And fullerenes are closed hollow cage of carbon atom, interconnected in the pentagonal and hexagonal rings. Each carbon atom on the cage surface is bonded to 3 other carbon atoms. Wow. Suppose if you take this carbon, it is connected to 1, 2, 3. In that way, each carbon atom is bonded to 3 other carbon atoms, and therefore it is in the sp2 hybridized state. And in the fullerenes, 12 pentagonal rings are necessary and sufficient to effect a cage closure. And fullerenes contain the carbon atom arranged as a combination of 12 pentagonal rings and n number of hexagonal rings. Fullerene cages are about 7 to 15 angstroms in the diameter and are 1 atom thick. The chemical formula is C20 plus 2N. So this is about the brief introduction of the fullerene and the structure of the fullerene. Coming to the types of the fullerene, due to the structural variations, fullerene exists in following different types, that is 3 types. There are many different types, but mainly we will study only 3 types. The first one is a buckyball cluster, nanotubes, and megatubes. Coming to the first type, which is known as the buckyball cluster, the smallest member is C20, which is known as unsaturated version of dodecahedrine. And the most common is C60. The most common fullerene is C60. But the buckyball cluster it is having is a small member ring, which is having only 20 carbon atoms. And coming to the carbon nanotubes, the second type, it is a hollow tube of very small dimension, having single or multiple walls. Potential application in the electronic industry is having the potential application in the electronic industry. Coming to the third type of the fullerene, which is known as the megatube. It is a large in diameter than the nanotube and prepared with walls of different stickiness. And it is also potentially used for the transport of variety of molecules of different sizes. I already told you that fullerenes are of many types. These 3 are the main, and there are other 2 fullerenes is also there, which is known as the polymer is the first one, and nano onions is also there. Polymer means it is having a chain, 2-dimensional or 3-dimensional polymers are formed under high pressure, high temperature condition. And nano onions, It is a spherical particle based on multiple layers surrounding a buckyball core proposed for lubricants. Coming to the preparation of the fullerene, a common method used to produce the fullerene is to send a large current between the nearby graphite electrodes in an inert atmosphere. The resulting common plasma arc between the electrodes cools into sooty residue from which many fullerenes can be isolated. The fullerenes are extracted from the soot using multi-step procedure. The best method is the arc discharge method. This method was first used by the Surrealism in the year 1991. It consists of the reaction chamber containing two graphites separated by a short distance of about 1 to 4 nanometer, and the chamber is filled with the inert gases such as the nitrogen, helium, argon, etc. A current of about 18 volts, that is 5200 angstroms, is applied across the electrode, and the carbon atoms are ejected from the anode. They get deposited on the cathode. That sooty residue from which many fullerenes can be isolated. The synthesis of product yield by this method is 60%. Coming to the properties of the fullerenes. Fullerenes are stable with sp2 hybridized carbon atom. The reactivity of the fullerene is increased by attaching the groups, that is active groups, in the surfaces. The characteristic reaction of the fullerene is an electrophilic addition at 6-6 double bond, that is at the position of 6 and 6, because it is having the 6-membered ring and the 5-membered ring, which reduce the angle strain by changing the sp2 hybridized carbon to sp3 hybridized carbon. When other atoms tapped inside the fullerene to form a compound known as endohedral fullerene. When the metal is used as an endohedral fullerene, it is called metallofullerene. The example for that is a steel. Next, coming to the solubility of the fullerene, it is sparingly soluble in many solvents. Common solvent for the fullerenes are the toluenes and carbon disulfide. Yeah, toluene and carbon disulfide. Coming to the next property that is known as the quantum mechanics. Wave particle duality is exhibited by the fullerene as a result of several sculpture symbolizing wave particle are created. Coming to the chirality, some fullerenes are inherently chiral because they are Jntu symmetric and have been successfully resolved. Resolved means separated. Hydrogenation is another property of the fullerene, which exhibited by the C6 molecule because it is having a small degree of aromatic character. undergoes the addition with hydrogen to form polyhydrofullerene. And the fullerene is also exhibit the property of halogenation. Halogenation means addition of fluorine, chlorine, bromine, which make to react with the C60 molecule under various conditions. It produces a vast number of halogenated derivatives. And fullerene is made to react with the oxygen also, mainly the C60 molecule. It can be oxygenated to form epoxides. And ozonization of the C60 in orthoxylene at 557 Kelvin, it gives ozonide, that is C60O3, which can be decomposed into two forms, that is C60O, and the same decomposition at 296 Kelvin, it gives the epoxide. When C60 is mixed with the disulfide, the radical C60SR is formed spontaneously, whose stability depends on steric factor. Metal complexes were produced with C60 fullerene by using the metal molybdenum, tungsten, titanium, etc. When doped with the alkali metal, doping means fullerene is mixed with the alkali metal. They act as a conductor and superconductors. And it is very difficult to oxidize, but it can be easily reduced. Because of the presence of unsaturation, fullerene shows broad UV visible absorption, and it reacts readily with the electron-rich species and acts as an acceptor of electrons and electronic energy. Coming to the applications of the fullerene, it has been used for several biomedical applications, including MRI, X-rays, drug and gene delivery. Buckyballs are efficient medium to make the hydrogen gas. So that's why the buckyball will be used to store the hydrogen, possibly as a fuel tanks for fuel cell. And fullerenes are used in the medical field, mainly the Cnt&Fullerene. It inhibits the HIV virus because C60 inhibits a key enzyme in the human immunodeficiency virus known as HIV-1 protease, which could inhibit the reproduction of the HIV. That means this Cnt&Fullerene is used in the treatment of HIV to inhibit the spread of HIV virus. When impregnated with the helium, C60 buckyballs can be used as a chemical traces in the human body. And it is also used to prepare the polymer composites with specific property. So fullerenes are also used to produce inexpensive solar panels because the optical absorption properties of C60 matches the solar spectrum. That's why it finds its application in the solar cells. And they are used in several applications like coatings, lubricants, catalysts, electronic and optical devices. In the next lecture, I'll explain about the liquid crystals. Thank you.